So in this video I'm going to show you how to make a data model to capture information about a community garden. So we have a garden down in here, and we want to track who's gardening in here, what plots they're gardening in, maybe what plants they're growing in that. And so what I'll show you is how we can create a data model in a database to do that. So the first thing is I need to get some data modeling software on my home screen. The one that we will be using is PG Modeler. And I'll click on it just to get it up and running. So PG Modeler is open. The first thing I need to do is just make a new diagram. Now the new, by default it calls it new database, and I need to get that switched to my A00 database. So I like to click on the objects window. Lots of ways to get there. And then I right click on the database and go properties, and I'll change the name. So you have to change this to your banner ID. Very important that the A is the lowercase a. And I'll just apply that. Databases and that typically just have tables in them. But before I start adding tables, I want to organize them in a schema so they don't collide with other tables I have. So I'll go over to schemas and go new schema. And I'll add one called dunsmuir. And I'll go apply. Now schemas aren't shown on the diagram, just typically tables and their relationships. We'll see it sort of indirectly though. So I should get started just adding tables. I need a table that's going to track gardeners. So table, click on the area, the drawing area, and I'll call this table gardeners, plural. I'll make this change, not the public schema, but my dunsmuir schema. And I'll add some columns. The first column I'm going to add is gardener ID. And I keep these singular, the column singular and the table plural. Small int is fine for now, and I'll go apply. And then I'll come in and add one called name, and that'll be varchar to store a name. So varchar is usually further down on the list, 45 characters wide, and apply that. And now I have sort of two columns in the database. I want to make some changes. I want to set gardener ID as the primary key and make name required. So I can double click back on the table, go back to columns, and to make a column required, you just check on not null, that it can't be null. And you'll see that the color has changed here, and also they have this NN constraint to say not null. Now to make a primary key constraint, you actually use the constraints tab, and you'll have to make a new one. And I like to call the primary key table name underscore p key. So again, gardeners p key. And again, you have a lot of choices here. Primary key is just the default because it's the most common. And then you have to pick which column do you want to use as the primary key. So I'll use gardener ID, and then you have to add it down here because you can't have more than one column acting as the primary key when you have a compound or composite key. And I'll go apply and apply again. And we can see that gardener ID now is blue and has this key symbol. So it's required and must be unique, which is the primary key constraint. Now gardeners garden in a plot, so make sure you click off the table so that's not highlighted. New table. Just click. This will be plots, plural. I'm going to add a couple of columns. Plot ID. I'm going to add another one called section. And it's going to hold one character. I'm still going to use a varchar just so that I keep things consistent. I also want to add another column called number. The thing, what a lot of people do, you see this even at the BCIT campuses, they take the campus and break it up into 4 quadrants. In this community garden, they broke it up into 4 sections, A, B, C, and D section. And then within that, they number the plots, so A4, D8 or something. So again, the name of this column is number. And small int will be fine. We will make it required. Apply. We'll also make section required. Okay. And one thing we have to do is basically set the primary key. And so I'll make a new constraint, and again this will be plots, P key and set the primary, which is what I want, and I want plot ID, and I add that, and I go OK and apply. And now I have my gardeners and my plots, but as you can see by the suffix, it's still in the public schema. So double click on the table, clear that out, and set it to dunsmuir. Apply. Now, I want to have a relationship of one-to-many between gardeners and plots. So a plot is managed by only one gardener, but a gardener can have several plots. And so the key to any of these tools is typically when you're doing one of these modeling tools is, do I click on the one table or the many table first? The MySQL Workbench, many. In this tool, you click on the one table first, which is the gardeners. So one gardener can have many plots. So we go relationship, make sure you pick one to many, click on the gardeners table and then the dunsmuir table. One thing I like to do is change the naming convention. I don't like a column table name, it gets too long. So the foreign key, when it drops it in, I just want it to be the same as the source column, and I'll go apply. And so that way, gardener ID is gardener ID, and it's not gardeners underscore gardener ID. So that gets a little bit too long for me. And you can also see that this has a different sort of icon, that is magenta, which is a common color used for foreign keys, but this one uses an arrow to say that it points back to this table here. And I like to keep my foreign keys to have the same name as my primary keys in the other table. And it has the FK symbol on the side to tell you that it's a foreign key as well. So what I need to do now is make a plants table. So make sure you click off on the area so that none of the tables are highlighted and go new table. And I'll click table. I'll call this plants plural. I'll make sure I do that change on the schema right away. And I'll add some columns. Plant ID, apply. And another one would be name of the plant. And I'll make that varchar 45 just to be consistent with the other table. I also want it to be not null, and I'll apply it. I need to make a constraint, the primary key. This will be plants P key. Primary key is good. Make sure you select the plant ID and then add that. And I'll go apply. So far, that looks good. It's required. And we have the primary key symbol. Now sometimes people, when they do queries on the database, they may not be interested in carrots or a certain type of beet or something like that. They just might say who's growing berries. So that might cover a whole bunch of different types of plants, or who's growing vegetables. And so we're going to make a table that would help us categorize the plants. So again, click off on the area so that the table isn't highlighted, and we'll go new table, and we'll call this plant types. Again, clean out the public and add dunsmuir. Enter. Now, I'll need some columns. Plant type ID. Change that back to underscore. So plant type ID, small int is fine, apply. And another one, we'll just make it name again. And we'll make that a varchar 45 like before. And now we have to set the primary key. So click on the constraints tab, hit the plus icon. We'll call it plant type or types PK. So the P key. And we just make sure plant ID is selected and then add it and apply. I'll also have to click back. It looks like it's good to go, and we'll go apply. One thing is we'll go back and make the name required. Now we need a one-to-many relationship between plants and plant types. So who's the one? Well, many of these plants can fall into the same category or plant type. So if that's the many, then plant type is the one, so we need to click that one first. So new relationship, one to many. Click on plant types first, and then plants. And again, I take off the table, I guess, suffix. I just want, when it copies the column over, to just have the same name as the one table. And I go apply. And we can see that it's added the column here. And that's how we link the tables together. So plant type ID, plant type ID. So I just like that. I'm old school. That's how I was taught. Plus, it also helps with something called natural joins. Now, the big relationship is that I want a many-to-many relationship between this plants table and the plots table. So again, make sure your table isn't highlighted. I go new relationship, many to many. Now, because it's a many to many, it doesn't really matter which one you click on first. They're both the many table. So plot, you can have many plants, and a particular plant can be growing in several plots. Now again, when you do, I like so that when it names the columns, because it is going to make a table in the background for us that we're not going to see, I just want it to have the column names. And we'll go apply. Now we can't see a table, right? We just see this many plots as many plants. But if we double click on that line and we go to advanced, we can see there is a table inside here. If we double click on the table, we can see that the table has two columns, plot ID and plant ID. And if you look at the constraint, the primary key here has two columns involved, plot ID and plant ID. And that's how a relational database basically resolves a many-to-many relationship by having an intermediate table. So in the diagram we won't see the table, but when we forward engineer this, we'll see 5 tables in the database. And there will be one called many plots has many plants. So one thing we do need to do is to validate our model to make sure that we put things in the right sort of area. One thing that could happen is that this table could unfortunately get put into the wrong schema, but we're hoping that it behaves, right? And we'll just do the validation now. So down at the bottom we'll see a validation tool that will try to validate the model. So it says that it failed, right? So could not connect to the database. PG Modeler has the ability to connect to your database and forward engineer the model right from here. I like to do it in a two-step process where I export the SQL, and I will show you that in a subsequent video. But if that's the only error, then we're good to go, and this concludes this demonstration.